Okay, so this is Bomb 5 of quantitative comparison of the GRE. We have a question here where they give us a circle centered O, and we have a triangle inscribed the circle, triangle ZOX. We have one of its sides is 3. We have an angle of the triangle P. They give us some restrictions. They tell us that the angle P has to be greater than 0 and less than 90. They gave us quantity A, which is the perimeter of the triangle inscribed the circle ZOX, and we have quantity B, which is 11. Again, as usual, we have to determine whether quantity A is larger than quantity B, whether quantity B is greater than quantity A, or whether both quantities are equal in value, or whether we don't have enough information to determine which one is larger. Alright, so before starting off with the circle aspect, I want to bring up an idea from right triangles. That is, for example, there's a famous right triangle that you should definitely know if you're going to take the GRE, which is the 1, 1, radical 2 right triangle. 1, 1, radical 2. Because these legs here are the same length, it means that their opposite sides are also the same. The angles opposite to the sides must be the same. This is 45, and this one here is also 45. Obviously, this is the 90-degree right angle. They satisfy the Pythagorean theorem, that is, the sum of the legs, each of them squared, equals the hypotenuse, which is in our case is square root of 2 squared. It satisfies that. So the important thing that we want to use from this right triangle in our question is that if I see a right triangle where the two legs are the same value, for example 10 and 10, I know that that's the same as grabbing this right triangle that we have here and just multiplying these two sides, these two legs, by 10, and also multiplying the hypotenuse by 10. So therefore I know without doubt that the hypotenuse has to be 10 radical 2. Because these two triangles are the same, it's just that I grab the legs and the hypotenuse and I multiply them all by 10. And that's the idea that we're going to use here in this question. Alright, so I see the triangle inscribed the circle, and now the question is, look, what are the possible perimeter values of this triangle here? Now I know that if I grab a triangle, for example, if I have a triangle like this, and I grab these two sides right here, and I open up the angle between them. For example, I open it up wide. I can see that the black side here is actually increasing in size. And obviously, if I close these two red sides closer together, I go back, for example, here, and the black side is smaller. So what that tells me is that the largest possible perimeter of this triangle right here is when this angle here is as large as possible. And what's the largest possible value that P can be? Well, they tell us here that P is at most 90. In fact, it cannot be 90. It has to be a little bit less than 90. So if I assume it's 90, I actually have a triangle with a perimeter that is larger than all the possible perimeters that I could actually create for this triangle. So I'm going to assume the extreme case. I'm going to assume that the triangle here inside this circle, ZOX, actually has a p-value of 90. That is, it becomes a right triangle. And I label it ZOX. This side is 3. Now notice that this triangle is inside the circle. And these sides here correspond to radii of the circle. And we know that the radius of a circle is the same no matter from where you take it. For example, this O to Z here is the same as this O to the X here. They have the same length. And if I draw another radius, for example, here, it also has a length of 3. So I know, based on that idea, that the other side of the triangle right here of ZOX also has a side length of 3. Oh, but notice, look, these two sides of the right triangle have length of 3. They're the same. And based on this idea that we talked about before, that's just like multiplying this triangle right here, the legs, all of them by 3, and also multiplying the hypotenuse by 3. So I know that the hypotenuse here has to be 3 radical 2. Again, this is the extreme case. Whatever perimeter we get here is going to be larger than any possible perimeter of the triangle ZOX. Alright, so what's the perimeter of this extreme case of a right triangle inscribed the circle O? Well, the perimeter is just the sum of its sides. So I'm going to add up 3 plus 3 plus 3 radical 2. Again, we know that this is 6. And what's 3 radical 2? Obviously, we don't know that off the top of our head. But again, the GRE has a mini calculator with basic operations, and you can actually find the square root there. And we know that, for example, if we do 3 times 2 raised to the 0.5 power, again, remember, raised to the 0.5 power is the same as the square root, and we get 4. So this is around 4.2. So let's take a look at that again. 4.24 something. So I'm just going to round to 4.25. I rounded upwards actually, and we get a value of 10.25. Now that's the extreme case. That tells us that all of the perimeters that are possible for that triangle inscribed the circle must be less than 10.25, and therefore they all must be less than 11. And based on that observation, we know that out of the options that we can choose from, quantity B is larger than quantity A. And obviously the options are A, B, C, D. We choose B because that means that quantity B is greater than quantity A. And that's how we solve this question. Again, a brief recap. We use the idea that if we have a right triangle, a certain right triangle that we know, and we just multiply all of the sides by a given constant, that will be a corresponding right triangle. It's a similar right triangle. So here, because we saw that we have 3 and 3, that means that we have a right triangle that will be the same as this one, but we multiply all the sides by 3, and therefore that tells us the hypotenuse is going to be 3 radical 2. Obviously, you can use the Pythagorean theorem to find it right away without using the idea of similar triangles, but that might take a little bit more time. And in the GRE, the thing that you want to do the most is try to maximize time. We took the extreme case. We said, look, the largest value that P can be is 90. So well, actually not 90, but less than 90. We assumed 90, so we actually have an extreme case where we have the largest perimeter, a perimeter that's larger than any of the possible perimeters. We found that that value is 10.25, and therefore, since all of the perimeters are less than 10.25, they must be less than 11. And that's how we chose quantity B. Alright, I'll see you guys in bomb 6. Or check out the other videos. I posted some videos before, and maybe that'll be a little bit of good practice. Take it easy.